So now in this chapter, we will study about how to find the surface area and volume of cone and sphere, right? So these two things we will cover in this chapter, right? So let's start this chapter, surface area and volume. Now, what is a right circular cone? What is a right circular cone? So what is a right circular cone? Suppose we have a right angle triangle, right? As you can see here, there is a right angle triangle, AOB. Can you see this right angle triangle? And this is right angled at O, right? Now, suppose you can rotate this right angle triangle somehow, right? About its one of the side, which is containing a right angle, right? So which sides are containing the right angle? AO and OB, right? So if you have a a right angle triangle, and if you rotate this right angle triangle about one of the sides containing the right angle, then the shape which you will get is a right circular cone, right? Okay, so if somehow you have a stick here, right, and you are able to rotate it, right, in some direction, right, this right circular cone along the side AO containing the right angle, then you can assume that you will get this figure, right? You can easily visualize that you will get this figure. So this figure is a right circular cone, right? So what is a right circular cone? It is a solid generated by the rotation of a right angle triangle about one of the sides containing the right angle, and that is a right circular cone. Is that clear? Right? So as you can see here, that the triangle, that is a triangle AOB, right, which we are rotating about OA, right, and it generates a cone. The point A is the vertex of the cone, right? What this point is called? This point is called vertex. Okay, A is the vertex of the cone. Its base is a circle, right? It is having a circular base. Cone is having a circular base with center O, right? O is the center of the circle, and the radius is OB, right? So here OB is the radius, right? So a cone is having a vertex, as you can see here in the diagram. Its base is circular, which is a circle having a center. You can see here the center is O. O is the center of the circle, and OB is the radius of the circular base, right? Now the length OA, this length OA is called the height of the cone. Okay, this length OA is called the height of the cone. Is that clear? And the length AB, the length AB is called the slant height. Okay, the length AB is called the slant height, slanting height of the cone, right? Okay, so these are the terms which are related to the cone. So A is the vertex, you can write down. A is the vertex of the cone. Okay, OB, that is the R, is the radius of the cone, or circular base, radius of circular base. Okay, AO is the height of the cone, and AB is the slant height of the cone. Slant height of cone, right? So I hope you have understood what is the shaped right circular cone, right? Which is generated by the rotation of a right angle triangle about one of its sides containing the right angles. In this, you can have a vertex, the point, the tip at the top, that is the vertex of the cone. It is having a circular base, right? Having some radius. As you can see here, OB. OB is the radius. This is the radius of the cone. Height of the cone is the side containing the right angle. This is the height of the cone. And this hypotenuse of the triangle is actually the slant height of the cone. So these are the different terms related to right circular cone, right? As you can see here, that it is clear that angle AOB is 90 degree. In the triangle AOB, angle AOB is 90 degree, right? So if the radius, this R, is actually the base of the right angle triangle as well, right? Is the base R here, the radius R, which is the radius of the circular base, is actually the base of the triangle, right? So if suppose this is R, right? This side, which is the height of the cone, is suppose H, right? And the slant height is suppose L, right? Okay. Height is represented by H, height of the cone, slant height is represented by L, and the base radius is represented by R, right? So if the radius of the base is r units, height is h units, and slanting height is the L units, then you can find within this triangle AOB, where angle AOB is 90 degree, so you can easily find L by the Pythagoras theorem. Yes or no? So L here is the hypotenuse, right? So according to the Pythagoras theorem, hypotenuse square is equal to the sum of the squares of the other two legs, means h square plus r square, right? Or you can say that L is equals to square root h square plus r square, right? So this is the formula for finding the slanting height, or you can say the relation between the slant height, the height of the cone, and the radius of the base of the cone. Is that clear? So this is the slant height, okay? Slant height of cone. So these are the formulas related to here. L is equal to square root of h square plus r square units, right? So since this is a slant height, it is always in units. So this is the first formula. Now, the volume of the cone is 1 by 3 pi r square h. This is the formula for volume of the cone. 1 by 3 pi r square h cubic units. Whatever units, it is in the cube, centimeter cube, meter cube, right, millimeter cube. This is the volume of the cone, where pi is the constant, 22 by 7. R is the radius of the base, and h is the height of the cone. Then we can have the area of the curved surface. If you can see here, right, it is having a curved surface. This is the curved surface, right? Okay, curved surface of the cone. And the area you can find for this curved surface, and the formula is, write down, area of curved surface. Area of curved surface is, curved surface of cone is pi r L. Pi r L is square units, right? Since it is an area, it is an area, so it is always in square units. Okay, so the area of curved surface of the cone, right, means curved surface area of the cone. The formula is pi r L, where pi is 22 by 7 or 3.14, r is the radius of the circular base, and L is the slant height. Now, the total surface area. The total surface area of the cone, total surface area of cone, right? So how we can find the total surface area of the cone? Now look at the cone here. Everybody please see to the screen. So there are two surfaces, right? This curved surface, the top one, right? If you can see the ice cream cup, which is cone in shape, right? Ice cream cone, right? So area of this curved surface plus area of this base, right? So there are two surfaces, the curved surface and the circular base surface, right? So what will be the total surface area of this cone? It is actually the sum of these two surface areas, right? That means the curved surface area and the area of the base. So if we add them, if we add these two areas, we will get the total surface area of the cone, right? So write down, total surface area of the cone is equal to area of the curved surface, area of curved surface, plus area of the base, right? So if you add the area of both the surfaces, you will get the total surface area for the cone. Now, what is the curved surface area of this cone? We have already seen the formula of it, that is pi r L, right? So pi r L plus area of the base. So what is the base? Base is a circle, yes or no? What is the base of the cone? It is a circle. And what is the area of a circle? That is pi r square, yes or no? Right? So it is simply pi r square. Right, so total surface area of the cone is pi r L plus pi r square. Please understand this. Everything is given in your books. No need to note down, but it is important to understand. Total surface area of the cone will become area of the curved surface, that is pi r L, plus area of the base, which is pi r square. That is the area of a circle, right? Because its base is a circle. Is that clear? Now you can take some common things outside. So pi and r are common, and that's how you will get L plus r within the bracket, right? So the total surface area, TSA, of cone is pi r into L plus r. Is that clear? So these are the formulas related to the cone, right? Okay, and you need to learn these formulas. Okay, you have to learn these formulas. So please remember, right? Slant height, volume of the cone, area of the curved surface or the curved surface area, and the total surface area, right? And here the pi is 22 by 7, right? Unless stated. Okay. So if it is not given, you can take pi is equal to 22 by 7. Else, if it is given like 3.14, then you can put that value, right? So these are a few formulas for the cone, right? So please learn them. So now let's see another solid, that is a sphere. What is a sphere? You have seen the objects like football, volleyball, throw ball, any kind of ball is actually having a shape of a sphere. As you can see here in the diagram, right? This is a ball which is having a shape of a sphere. Or in geometry, you can say that the solid generated by revolving a circular lamina about any of its diameter is a sphere, right? So how you will get the shape? Suppose you have a circular lamina, right? This is suppose a circular lamina, right? And it is, and this is suppose the diameter. This is circular lamina, right? And there is a diameter, right? And we are rotating this lamina, yeah, right? So there is a stick which is attached to here, right? So this is the diameter, AB is the diameter, suppose, right? And there is a stick attached here, and now you are rotating it, right? In any direction, either clockwise or anti-clockwise. So the shape which will be formed is a sphere. I hope you are able to visualize that. Yes or no? If suppose you have a circular sheet, suppose you can do it this, you can try this at home also, right? So just take a cardboard, right, of circular shape, okay, and try to rotate it, right, about it, any of its diameter, right? You can take a stick attached to its one of the diameter, right, and then rotate it, right, frequently, right, rotate it, right, in a fast way, right? You can see that there is a shape which is formed by the rotating this lamina, and this shape is sphere. Is that clear? Okay. So there are certain formulas which are related to sphere again, right? So there is a center of the sphere and the radius of the circle, which is rotating to form this solid, so form the shape that is a sphere, right? So it must be having some radius, right? So there are two things here, center and radius of the circle, right? And the same is the center and the sphere of the sphere. So इसका जो center है और इसका जो radius है, वही sphere का center होगा, वही sphere का radius होगा. Is that clear? So for solid sphere of radius r units, we have certain formulas, right? The first formula is volume of the sphere, and volume of the sphere is 4 by 3 pi r cube. Okay, volume of the sphere is 4 by 3 pi r cube, cubic units. It is always in cubic units because this is a volume. So it is either millimeter is cube or centimeter cube or meter cube, right? So these type of units will be there. And then we have surface area. There are only two formulas related to sphere, that is the surface area and volume. Surface area of the sphere. Surface area of the sphere is 4 pi r square. It is 4 pi r square units. Right? So here we do not have the separate curved surface area and the total surface area, because in a sphere we have only and only one surface. There is no other surface in the sphere. Right? So a sphere is actually circular in from any face. If you can see it from any side, it is a circle, right? Okay, so there is only one and one surface, that is the curved surface, right? And therefore we have only the surface area of the sphere, which is equal to the 4 pi r square. Right? So these are the two important formulas related to sphere, right? So please note down. Now, if suppose there is a solid which is enclosed between two concentric spheres, means there are two spheres which are concentric sphere, right? One sphere is inside the other, right? So this makes a spherical shell, as you can see here in the diagram, right? So these are the two concentric spheres, right? And this makes a spherical shell, right? So this is the spherical shell. This one is a shell, okay, which is formed when two spheres are concentric. Is that clear? And these spheres have different radius, as you can see in this diagram, small r and capital R, right? Okay, so these are the two radius of the spherical shell, or you can say the external radius and the internal radius of the spherical shell, right? So now we can find out the volume of this spherical shell as volume of the spherical shell by the formula. So how do we find the volume of the spherical shell? If we subtract the volume of the inner sphere from the volume of the outer sphere, yes or no? Right? That means 4 by 3 pi r cube minus r cube, right? So what we have done here, we are actually subtracting the volume of the inner sphere from the volume of the outer sphere, having the different radius, small r and capital R. Okay, so if we subtract this and then we take 4 by 3 pi outside, which is common, so you will get r cube minus r cube within the bracket, right? So in this way, we can find out the volume of the spherical shell, which is enclosed by two spheres of different radius. Please note down. And this is always in cubic units. Okay, cubic units. Since it is volume, it is always in cubic units. Now, what is hemisphere? As we know that if we cut a ball into two pieces, right? It is something like this, as you can see here in this figure. Yes or no? Right? So what is hemisphere? When a plane through the center of a sphere, it cuts, right? It cuts it into two equal parts. Then each part is called a hemisphere, right? So this is a hemisphere and this is also a hemisphere, right? So when we cut a sphere through a plane within the center, right? There are two hemispheres which can be obtained, right? So these are the two cut part of that sphere, and each of them is called a hemisphere, right? Radius of these hemisphere is still r, okay, right? The radius of the hemisphere is the r, as you can see here. Both are same, r, right? Now we can find out the volume of the hemisphere, curved surface area, and the total surface area. Now, if you look at the hemisphere, any one hemisphere, if you consider, right? Now, because we cut this, cut the sphere into through a plane, right? Now there are two surfaces. In the sphere, you have only one surface, that is the curved surface. But in hemisphere, you have two surfaces, right? What are these two surfaces? This surface, which is a curved surface, okay, and there is a flat surface right here, which you can see, which is a circular base, which is a flat surface, right? So in this way, there are two surfaces which are obtained in the hemisphere, that is the curved surface, and the base, which is circular in shape, right? So now, what will be the volume and the curved surface area and the total surface area for hemisphere? So volume of the hemisphere is actually the half of the volume of the sphere, right? Because we have cut that sphere into two, right? So what was the volume of the sphere? Volume of the sphere was 4 by 3 pi r cube, right? So if we divide this by 2, we will get the volume of the hemisphere, right? So 4 by 3 pi r cube, right? And if you divide this by 2, right, this will become 2, and that's how you will get 2 by 3 pi r cube, right? So what will be the volume of the hemisphere? Volume of the hemisphere is 2 by 3 pi r cube. So you can directly write it down, 2 by 3 pi r cube, which you can obtain by dividing the volume of the sphere by 2. Okay, cubic units. Okay, so this is the volume of the sphere. Now, since there are two surfaces, curved surface and the circular base, which is a flat surface, so we can have the two surface areas here, the curved surface area of hemisphere, right? And this is equal to 2 pi r square, right? If you can see here, what is this? Right, this is actually the half of the surface area of the sphere, right? So what is the surface area of the sphere? It is 4 pi square, 4 pi r square. If you divide this by 2, right, you will get 2 pi r square, which is the surface area, curved surface area of the hemisphere. Is that clear? So this is 2 pi r square. right? 2 pi r square units. Okay, so this is the volume of the sphere and the curved surface area of the hemisphere. Now, the third formula in hemisphere is the total surface area of the hemisphere. Total surface area of the hemisphere. And you can get total surface area of the hemisphere if you add the curved surface area plus the base area, right? So what is the curved surface area? It is 2 pi r square, right? So write down here 2 pi r square. And what is the base area? Since its base is a circular base, right? So what is the area of the circle? That is pi r square. So if you add them, right? So base area will become pi r square. Now you can add to get the total surface area of the hemisphere, which is 3 pi r square units, right? So this is the total surface area of hemisphere. Is that clear? So in this way, we have these three formulas for hemisphere, right? Whose radiuses are. So volume of the hemisphere is exactly half of the volume of the sphere. That is 2 by 3 pi r cubic units. Curved surface area of the hemisphere is exactly half of the surface area of the hemisphere. Sphere. That is 2 pi r square units. And the total surface area of the hemisphere is the summation of curved surface area and the base area, right? And this is 3 pi r square, right? So you have to learn these formulas, right? For the cone and sphere, all the questions will be based on this. And you can say the whole chapter is actually based on these formulas. So now in the next class, we will do the questions based on these formulas. Till then, just revise it and learn them. Is that clear to everyone?